snowboarder of mass m is traveling with velocity v1 when he enters a circular arc AB at a point A. AB has a radius 6.7 and a center C. A, B, and C lie in the vertical plane. The student models the effect of a snowboarder ignoring the effects of friction and air resistance. No friction, no air resistance. Draw a diagram to show the force acting on a snowboarder when he's at the point D. Okay, so what we're going to do is I'm just going to snip out the this here. Put it down here. Here we go. So what we do is we might treat it as a block, point D or point particle. Okay. Now what we'll have is the R. What's the R, guys? The reaction. Sorry, the capital R. The reaction force. Always back towards the center of the vertical circle you're on. Okay, along the radius. What do we have going downwards? Mg or weight, and that's enough for full marks. We all cool with that? Okay. Now, what else is one from me? Express the reaction force of the snowboarder at point D in terms of M, V1, and A. Alright, no hassle. I'm just going to take this picture and bring it down with me. Okay. Should be here in a sec. There you are. Now, nice big diagram. So here's what we're going to do. We'll have this here. Now, for part 2. Okay, so would you all agree the reaction force is going here is R? We have mg going down. Okay, now what's the rule for vertical circle? What's the trick we always do? Anybody remember? You always resolve the forces in what direction? Parallel and perpendicular to the radius for vertical motion. Which force is not parallel or perpendicular to the radius currently? Mg is the only one we got to fix. So let's do our little opposite angle trick. What angle's this one? This one here? Alpha, yeah? And then if I go straight through Mg and create a right angle triangle, what angle is this one here? It is alpha, yeah. Which makes this Mg cos alpha is the purple one. And then if you want a different color, the blue one is Mg sine alpha. Now, when we're talking about centripetal force, yeah, will I use mr omega squared or mv squared over r? Which one should you choose and why? Why? And it mentions v, doesn't it? So there's your shot selection sorted. You know the reason why. Oh. Okay, happy enough with that? Now, what we're going to do next is the following. We're going to... What I think we should do is we know that the speed... Oh, it says in terms of V1, doesn't it? No. I haven't got a V1 to play with just yet. So I'm gonna just sub in what I have, okay? So do you all agree it's it has to be going towards the center of the circle. Centripetal force always goes towards the center of the circle. So do you all agree that that's R minus mg what? Mg cos alpha, yeah, equals m. It does give it the m is just the m, isn't it? There's no mass for the snowboarder, is there? Nope. V squared, which is its current velocity, not the v1 we were asked for at the start. So, and then all over 6.7. What's technically wrong with our answer? It shouldn't be V1. Sorry, it shouldn't be V. It should be... Exactly. So we're going to park that for a minute. That equation's perfect. Okay, we're going to park it and we're going to go back to work again. Going to go back to our diagram. And what's the second thing we always do on vertical motion? I usually do it first. I don't know why I went for the centripetal force first this time. Conservation of energy. Yeah. So mgh1 plus a half mv1 squared equals mgh2 plus a half mv2 squared. Okay. Why am I currently drawing a line through A? What does that horizontal line mean? Anybody remember? A couple of weeks ago we were doing this. It means the H value is 0 at the point A. We cool with that? Now what I'd love to know is, I'd love to know this red distance here. See that red distance? That red distance is actually H2. And I'd love to know how to get H2. Anybody have any ideas how to find H2? Actually, I should use a different color for that. Alright, let's do some trigonometry to find H2. Could anybody tell me what this purple distance is? Might be a good call. Anybody got a way to find that purple distance? 6.7 cos A. Because if I call that x, cos A would be x over 6.7. So x on its own is 6.7 cos A. Now, does anybody know how to find the red line then? Do you want we call the red line? So the purple line plus the red line. So 6.7 cos alpha plus H2 results in what distance? What happens if I drag this all the way over? What happens when I add both of them together? They're the same as the radius of the circle. Now, so what does that mean? What does that make H2 then? Anybody know? 6.7 take away. We all right with that? Now, we're over here. Now, we're gonna fill in this. We're gonna fill in this one now. So we're gonna have mg0. Why is it mg0? Your height is 0 to start. Plus a half mv1 squared because it's v1. And then we're gonna have mg. What's it? 6.7 take away. 6.7 cos A. Plus a half mv squared. Cool. Do you remember what I told you was the transfer conjugate between both, the transfer mechanism between both equations is always mv squared. So I'm going to isolate mv squared on this equation here, yeah? So first things first, I'm going to multiply that out and then I'm going to bring it over to the other side. Is that okay? So what I'm going to get is 6.7 mg cos alpha minus 6.7 mg plus a half mv1 squared equals a half mv squared. And then I'm going to multiply both sides by what number? 2 to isolate what mv squared is. Twice 6.7 is 13.4 mg cos alpha minus 13.4 mg plus mv1 squared equals mv squared. We all good? Okay. Next thing we're going to do, see this equation here? I'm going to grab it and I'm going to drag it all the way down. All the way down. Do what you're told. No. Oh no. It's the joys of it, isn't it, guys? Here, try this one more time. Just gonna cut it and paste it, might be the best bit. Now I bring it down cleanly, okay? Now, I'm gonna sub out that MV squared for what? Yeah, all that stuff, isn't it? 13.4 mg cos A minus 13.4 mg. What's the next part? Plus mv1 squared. Why do I have 6.7 on the bottom again? Oh, it was the radius was on the bottom already, wasn't it? Now, what's the goal of the question? To isolate? The goal of the question is to isolate R. And it says mv1 and alpha is allowed. Okay. I might, yeah, I'll cross multiply up to 6.7 temporarily to get 6.7 R minus 6.7 mg cos alpha. Okay, equals all of that again. They all equal each other, okay? Okay, next thing, 6.7 R equals, bring the 6.7 over to your side, and what do we get? What's 6.7 plus 13.4? I think it's like 20.1, is it? And then divide all that by 6.7 and I'm done. Marking scheme, what they did was they divided by 6.7, so they divided 20.1 by 6.7, they turned that into 3 mg cos alpha. They divided the 13.4 by 6.7 and they got minus 2 mg, and then they just left the mv1 squared over 6.7 in the corner, and that is what they got. Part 2. Express V2 in terms of V1. The snowboarder reaches a point B with vertical velocity, V2. Now where's point B again? Oh, okay. So we're going to have to, I think we might be doing the conservation of energy again. So we do cut, bring this over here. Where's my picture? Okay, paste it in here. Here we go. So I think what I'm dealing with here is I'm dealing with V2 is him going straight up into the air, isn't it? Agreed? How much height has he got above the ground at this point? From here to here. Would you agree it's the same as the radius? It's the same as that one there. So what do you reckon the height is? Yeah, I'm gonna go for conservation of energy again. Because I'm gonna go for mg0 for a half mv1 squared for your speed, for your kinetic energy, mg 6.7 for your potential energy, and then a half m v2 squared. Okay. And that's exactly what they want from you, actually. So I'm going to multiply... Going to multiply both sides by 2 and get rid of the m's. So it's going to be v1 squared equals 13.4g and then v2 squared. Very close to having this done, haven't I? What's next? v2 squared equals v1 squared minus 13.4 g. You could actually do this part without doing the previous part. This part was actually easier than the previous part, so that's something to know for in exams. So what's happened is the snowboarder leaves the arc, doesn't he? And he goes straight up in the air. And what forces are at play now? Your weight going downwards. Now he wants an air resistance model as well, so we call that MK, V going downwards, and that's it.